Hey, everyone out there getting ready for those senior software engineer interviews. Those are always high stakes, so we're here to help you feel prepared.
Absolutely. And we're not just talking about the coding challenges you might face, but really diving deep into the tech landscape you'll likely encounter, especially in the world of microservices. What the seasoned interviewers really expect you to know.
Yeah, think of it like we're sharing some of the secret sauce, so to speak, the insider knowledge that can help you stand out as a strategic thinker, not just a coder.
Exactly, because at the senior level, it's all about demonstrating that you understand how systems work at scale, particularly in these distributed environments.
Okay, so let's jump right in before we even talk specific technologies.
Yeah.
What are some fundamental concepts that really signal to an interviewer, hey, this candidate really gets microservices? There are four key areas that I would say form the bedrock of a solid microservices approach, and those are log aggregation distributed tracing containers with Kubernetes and streaming. These aren't just buzzwords. You can sprinkle on your resume. These really show that you understand the core challenges and solutions in this microservices world.
Okay, let's break those down then, starting with log aggregation, which I know might sound basic, but why is it such a must-have, not just a nice-to-have?
Well, imagine you're in a system where requests are bouncing between hundreds of services, right? If something goes wrong, how do you even begin to debug it without a centralized way to collect and analyze logs from every single part of your application? So log aggregation is like having this bird's eye view of the entire system so you can quickly pinpoint issues and understand the flow of events.
So it's not just about finding errors, it's about understanding the overall health and behavior of the system.
Exactly. And here's where it gets really interesting. For a senior engineer, think about how you can use this wealth of log data to proactively identify potential issues before they become major problems.
Yeah.
Maybe you notice a pattern of increasing response times in a particular service that's assigned to investigate and optimize before it impacts users. And that's the kind of proactive thinking that sets senior engineers apart.
Right. It's about taking that system-level view, using the data to anticipate problems and prevent them now. How does distributed tracing build on this foundation of log aggregation?
Well, distributed tracing takes things a step further by allowing you to follow a single request as it travels through your entire microservices landscape. It's like a detective following a trail of breadcrumbs. Tools like Jaeger or Lightstep. These let you visualize this journey, identify bottlenecks, and really understand the dependencies between your services.
So instead of just knowing that there's a slowdown somewhere, you can actually pinpoint exactly which service or interaction is causing it?
Precisely. And that level of granularity is essential for optimizing performance in a complex system. Let's say you have a checkout process that's suddenly taking longer than usual with distributed tracing. You can trace that request through each step, identify the bottleneck, and then focus your optimization efforts exactly where they're needed.
That makes a lot of sense now into containers and Kubernetes. I feel like this is often seen as a sign of maturity in the microservices world. What makes them so important?
Well, containers provide that crucial isolation between services, preventing a single misbehaving component from bringing down the whole system. It's like giving each service its own little apartment to live in, ensuring that one messy roommate won't ruin the whole building. And then Kubernetes acts as that building manager, orchestrating the deployment, scaling, and management of all those containers across your infrastructure.
I've heard that managing Kubernetes yourself can be pretty complex, though. What's the best way to approach that, especially in a fast-paced environment?
Yeah, you're right. Kubernetes can be a beast to manage on your own. That's why managed Kubernetes services from cloud providers are becoming increasingly popular. They handle all the heavy lifting of the infrastructure management security upgrades, letting you focus on building and deploying your applications.
So it's about choosing the right tool for the job and understanding when to leverage those managed services to streamline your operations.
Exactly. It shows you're thinking strategically about resource allocation, focusing on what truly adds value to your role as a senior engineer.
All right, let's move on to our last foundational piece here, streaming. How does this fit into the microservices picture?
Streaming is all about moving from batch processing to real-time data flows, which is crucial for building responsive and scalable applications. Think about it like the difference between getting a monthly bank statement versus having up-to-the-second updates on your transactions.
Ah, okay, I see. So instead of processing data in these big chunks, we're handling it as a continuous stream, which enables much faster insights and more dynamic interactions.
Precisely. And for a senior engineer, it's not just about knowing how to use, something like Apache Kafka, which is a popular choice here. It offers robust message queuing stream processing capabilities, but it's about understanding when and why streaming is the right solution for a particular problem.
This is already so helpful. We've covered log aggregation, distributed tracing containers with Kubernetes, and streaming as our foundational pillars.
Absolutely, mastering these concepts. It really demonstrates a solid understanding of the core principles of microservices, and this sets the stage for a successful interview.
Let's pause here for a moment. When we come back, we'll explore how these foundational pieces fit into the bigger picture of the public cloud. And serverless, see you in part two.
Welcome back. All right, so now let's shift our focus to the public cloud, which has become almost synonymous with modern microservice development.
Yeah, it seems like every tech interview these days involves some level of cloud expertise. What makes the cloud such a game changer for microservices?
Well, the public cloud offers this vast ecosystem of managed services that can dramatically simplify the complexities of building and running microservices. So instead of spending time and resources on infrastructure management, you can tap into services for databases, messaging queues, container orchestration, and so much more. This frees you up to focus on what really matters, delivering value through your applications.
So it's about offloading the heavy lifting and focusing on that core business logic rather than getting bogged down in the nitty-gritty of infrastructure management.
Exactly. And the beauty of these managed services is that they're designed with scalability and resilience in mind. They leverage the cloud provider's expertise and economies of scale, allowing you to build highly available and fault-tolerant systems without having to reinvent the wheel.
Now, one term that often comes up in the cloud world is serverless. I feel like it's become a bit of a buzzword, but is it truly a useful paradigm for microservices?
Serverless is a powerful concept that shifts the focus from managing servers to purely managing code.
Hmm.
Function as a service, or FaaS is a prime example of this. Instead of provisioning and managing servers, you deploy your code as functions that are triggered by events like an HTTP request or a message on a queue.
So it's like saying, here's my code, run it when needed, and I don't care about the underlying infrastructure.
That's the essence of it. The cloud provider takes care of scaling the function instances up and down automatically based on demand, ensuring high availability and efficient resource utilization. You only pay for the compute time your functions actually use, making it a cost-effective option for many use cases.
That sounds incredibly convenient and efficient. But how does this conceptual shift from server counts to pure code deployment impact a senior engineer's role?
It requires a different way of thinking about architecture and design. You're no longer concerned with the traditional aspects of infrastructure management, like server provisioning, operating systems, or patching parts. Instead, you're focused on decomposing your application into small independent functions that can be deployed and scaled independently. This allows for greater flexibility and agility in development and deployment.
So it's about embracing that flexibility and scalability of serverless and leveraging it to create more efficient and resilient architectures.
Precisely, and that's a key takeaway for anyone preparing for a senior engineer interview. Understanding how to leverage the public cloud and serverless technologies is essential for demonstrating your ability to design and build modern, scalable, and cost-effective systems.
It sounds like understanding the nuances of these technologies is a great way to stand out and showcase a deeper understanding of the current landscape. Are there any other specific skills or areas that you think are crucial for senior engineers to highlight in these interviews?
Well, it's interesting because we talk about a lot of different technologies here, but I think the real key is not just knowing about them, but being able to talk about them in a way that shows you understand the why behind them. Why is log aggregation so important in a microservices environment? Why is distributed tracing crucial for performance optimization? Why are containers and Kubernetes such a game changer? And how can streaming really transform the way you handle data, if you can articulate those reasons? That shows that you're not just a coder. You're an engineer who understands the big picture and the trade-offs involved in making these architectural decisions.
Yeah, it's about showing that you can think critically and strategically about the technology and how it all fits together.
Exactly.
Yeah.
Being able to connect those dots and articulate your thought process is what really sets a senior engineer apart from someone who's just starting out in their career.
So it's not just about having the knowledge, but it's about being able to communicate that knowledge effectively.
Absolutely. When you're interviewing for a senior role, you're not just expected to know the answers. You're expected to be able to explain them clearly and concisely and to defend your choices. You need to be able to articulate why you chose one technology over another or why you designed a system in a particular way.
So it's about showcasing that you have that deep understanding and you can also communicate it effectively.
Exactly. And that's what will ultimately make you a successful senior engineer.
This has been such a fantastic deep dive. Thanks so much for sharing your insights with us.
My pleasure. I hope this helps our listeners feel more confident and prepared for those senior engineer interviews.
And for all of you out there listening, we wish you the best of luck in your job search. And remember, it's not just about what you know, it's about how you communicate what you know. Good luck.